Right now, our solar system is floating safely through a quiet pocket of space. But eventually, our luck runs out. The Milky Way is often pictured as a majestic, orderly swirl, but it is actually a highly chaotic environment. Billions of stars are zooming around the galactic center, with our own solar neighborhood shifting constantly as neighboring suns fly past at hundreds of kilometers every second. Vast stretches of empty space currently keep us out of harm's way, but in the deep future, we could easily drift too close to a star going supernova or pass by a massive object whose gravity knocks millions of apocalyptic asteroids directly toward Earth. Because space is so incredibly vast, astronomers would see these hazards coming thousands or even millions of years in advance. But knowing the end is near doesn't help if we have no practical way to evacuate billions of people to another star system. Curious, lighter tone. To save Earth, we don't need massive fleets of colony ships. We only need to move the sun. Every other object in the solar system is permanently glued to it by gravity. Where the sun goes, we automatically follow. Surviving the long-term chaos of the galaxy requires turning our entire solar system into a vehicle. We have to build a megastructure capable of steering a star. The most straightforward way to move the sun is a megastructure known as a Shkadov Thruster. It is a colossal passive mirror built on the scale of a Dyson Sphere, relying entirely on the physical force of sunlight. It operates using radiation pressure. If an astronaut turned on a flashlight in space, the momentum carried by the escaping photons would push them backward very, very slowly. The sun produces enough photons to do this on a massive scale. As this diagram shows, we would build a giant micron-thin mirror out of lightweight aluminum foil and hover it directly over one of the sun's poles. By shaping the mirror as a parabola, we can reflect up to half of the incoming solar radiation and bounce it around the sun in a single direction. This generates a steady thrust without accidentally focusing concentrated heat back onto the star or cooking the Earth. The structure wouldn't even need to orbit. It would stay locked in one place, perfectly balanced. The sun's enormous gravity pulls the mirror inward, while the intense radiation pressure of the bouncing photons props it right back out. But there is a serious catch. At full throttle, this engine could only push the solar system about 100 light-years over the course of 230 million years. Because it must sit strictly over a pole to avoid freezing or burning Earth, our travel options are severely restricted. A giant mirror proves that steering a star is physically possible. But if an exploding star is in our immediate path, we need a much faster engine to get out of the way. To gain serious speed, an astrophysicist designed an active propulsion system for us called the Caplan Thruster. Rather than passively reflecting light, it works exactly like a traditional rocket. Shoot exhaust one way to push yourself the other. This diagram outlines the first stage of the engine. A massive Dyson Sphere structure gathers sunlight and refocuses it onto specific patches of the star's surface. The extreme localized heat boils billions of tons of stellar mass right off the sun. That boiled material becomes our fuel. Enormous electromagnetic fields act like a net, funneling all that raw hydrogen and helium out of the solar wind and directly into a central space station platform. Inside this platform, thermonuclear fusion reactors explosively burn the captured helium. This creates a jet of radioactive oxygen reaching nearly 1 billion degrees, which is fired out of the solar system at 1% the speed of light to provide massive forward thrust. To keep this giant station from falling into the sun, it uses a tugboat mechanic. Particle accelerators take the leftover hydrogen and fire a second jet backward. This balances the thruster and physically pushes the star forward. You might wonder if stripping billions of tons of matter away would destroy the sun. In reality, the sun is so massive that this barely scratches the surface. Because lighter stars actually burn their fuel more slowly, this process forcefully extends our sun's life by billions of years. With the speed problem solved, we no longer have to drift aimlessly. We can transform our solar system into a fully maneuverable galactic spacecraft, ready to steer clear of any cosmic disaster. This engine grants us near total control over our galactic orbit. In just 1 million years, a Caplan thruster can move the entire solar system 50 light-years, providing enough distance to dodge an incoming supernova. But we don't have to stop at evasion. Our far future descendants could throttle up the engine to intentionally orbit backward through the Milky Way. As other star systems safely pass by, we could send out ships to systematically colonize them. We could even aim outward and leave the galaxy entirely. We could explore the universe without ever exposing our species to the freezing, terrifying void of deep interstellar space, because we brought our home star with us. Steering a burning star across a galactic map requires a profound leap in how we think about time. These are machines built by civilizations that plan their survival not in terms of years or decades, but in eons. By engineering a stellar engine, humanity would no longer be adrift on the tides of the galactic sea. We would take the wheel, charting our own course through the cosmos for millions of years to come.